Earlier in Calc 1, we studied differential equations and how to solve a differential equation. And if you don't remember what a differential equation looked like, it was usually just an equation that had a derivative in it. Like it might have looked something like that. And if you recall, when we solved that differential equation, we would generally start by cross multiplying so that we could separate the variables. And then we would actually take the integral of both sides and get an answer. We're going to run into some problems because so far we've always dealt with ones where we could actually find an integral. But if I had something like dy dx is equal to x minus y, and I tried to solve that and tried to cross multiply, I would never be able to actually separate the variables. So we would be stuck, and there are going to be a few other cases where we're just not actually able to find an actual equation. So what we are going to do instead is use Euler's method to approximate the solution. At the end of this lesson, you'll be able to use Euler's method to approximate the particular solution of a differential equation. All right, lots of different wordy stuff here. I'm just going to highlight a few of them. Right, your answer, biggest thing here, is going to be a table of values because we're not actually going to find the equation. We're going to find points that would model the equation. So it's going to come very close to actually what the actually solution would look like. All right, so we'll just get a visual picture of what our curve looks like. All right, and I already mentioned if we can't find an exact solution ourselves, that's a good way to go. All right, so we're given an initial condition, x sub 0, y sub 0, and let's just say that my solution curve looks something like this. All right, what we're going to try to do is just try to find some points that are on that solution curve without actually finding the curve. So again, without knowing the actual equation, we're just going to try to model what it would look like. So we're going to start with x sub 0, y sub 0. It says the graph has a slope of y prime or dy dx. So basically what we are going to be doing with that, and instead of dy dx, we're looking for the slope. So if I'm looking for the slope, you will notice that I have, what I'm trying to find is I'm going to start with this point, and I want to get to this next point. So we're going to actually just follow the slope of it, which is rise over run. This rise is going to be the difference between the y values, and we're just going to call that delta y, the change in the y values. And the run is going to be the difference between the x values, which we'll call the change in x. So our slope is going to be delta y over delta x. And what we're going to try to be doing each time is we'll use that slope formula to get the next point. And then we'll use the slope formula again to get the next point. And then we'll use the slope formula again to get the next point. So all we're trying to do is just finding the slopes of the little segments that are running in between the points. Right? The biggest thing that we're going to use those, since slope in calculus, we know that the slope is equal to y prime. So instead of using an m, we'll use y prime. And what's going to be happening, we will be given enough information in the problem so that we'll actually be solving for delta y every time. All right, so we're just going to jump into an example and see how we do. Right, the example says to use Euler's method to calculate the first 3 approximations to the given initial value problem for the specified step size. So this is just, this h, and I forgot to say it from the previous page, this h really just means the change in x. How far are we going over in the x direction? So we're going to go over 0.1, which means we need to figure out how high up we need to go. We need to find the delta y. All right, and since it gives us the first 3 approximations, we're only going to be finding 3 more points on the curve. So again, we could, if we really wanted a good picture, we could go out many more, but we just mostly want to get the gist of what's going on here. So we're going to have an x and a y. They did tell me that my initial value was 0, 1, so my initial point is going to be 0, 1. And then from there, since my step size is 0.1, my next x value would be 0.1. And then my x value would be 0.2, and then 0.3. And I need 3 of them, so 1, 2, 3 approximations. So I am set to go. All right, for my first approximation, I'm going to, again, we're going to start with the slope is equal to delta y over delta x, and keep in mind that the m is really just y prime. So what we're going to do, since I have the point 0, 1, we are going to actually calculate y prime with 0 and 1. So since x is 0, minus y is 1, we will get -1 for that answer. We don't know what delta y is, so we'll just keep that. And then delta x, the change in each of the x values is 0.1. So if I cross multiply, I'm going to get delta y is equal to -0.1, which means the change in the y values from the point that I'm starting at to my next point, I'm going to have to subtract 0.1. All right, so that means that my new y value is going to be 0.9 because 1 minus 0.1 is 0.9. So we're ready for the second approximation. And again, we're going to start with m is equal to delta y over delta x. And again, we know that m is really y prime. And this time when we go to find y prime, we have a new x and a new y. So my x is going to be 0.1 minus my y value is going to be 0.9. 0.1 minus 0.9 will give me negative 0.8, and then I'll get the change in y. The change in x, again, the step size was just 0.1. It's going by 0.1. So again, if I cross multiply, I'm going to get delta y is equal to negative 0.08, which means to get from this point that I'm at right now to the next point, I'm going to have to subtract 0.08. Okay, so my new value, if I do that, will be 0.82. So now I'm ready for my third approximation. Again, we'll have m is equal to delta y over delta x. M is really just y prime. So y prime for this specific example, now my x is 0.2 minus a y value is 0.82. So 0.2 minus 0.82 will be negative 0.62 is equal to the change in y over the change in x, which again is 0.1. Notice the change in x will be the same every time, it's just the step size. And then if I cross multiply again, I'm going to get delta y is equal to negative 0.062. So we know to get from the y value we're at to our new y value, we will have to subtract 0.062. And if we do that, we will get 0.758 as an answer. So what I've done is come up with, if I were to graph all four of those points, it's going to give me a good idea of what the actual solution curve looks like. Alrighty, let's try another example. I would strongly encourage you on this one to go ahead and pause my video and see how you do on it, and then come back and see if you got it right. Okay, so the first thing that I'm going to do is go ahead and make my XY table. Alright, my x starts at 0. This is my x and this is my y, so it starts at 0, 3. My step size is 0.2, so my next one will be 0.2, and then my next x value will be 0.4, and then my next x value will be 0.6. So that's how I get my x values. I'm ready for the first step. Alright, so step approximation 1, we've got m is equal to delta y over delta x, and of course m is just your y prime. Well, they did give me y prime, so for this first one I'm going to have 2 times the y value, which is 3, and then the x value is 0 plus 1. So if I do that, I will get 6, and then that will equal the change in the y over the change in x, which we already know is going to be 0.2 every time. So if I cross multiply, I'll get delta y is equal to 1.2. So since I got a positive 1.2 to get from my current y value to my new one, I'm going to have to add 1.2. Alright, so step approximation 2, if I added 1.2, I'm going to get 4.2. So we're going to have m equals delta y over delta x again, and my m is just my y prime, so to figure that out, I will do 2 times the new y value right now is 4.2, and then x is 0.2 plus 1. So if I work that out, I will get 10.08, and that will equal delta y over 0.2, because that's my change in my x's. If I cross multiply, I'm going to get delta y is equal to 2.016, and that, since it's a positive, that means I get to add that to my y. Alright, so to do the third approximation, first of all, if I add 4.2 to 2.016, I will get 6.216. So the next thing that I need to do is to do my third approximation. I am going to do, again, m is equal to delta y over delta x. My m is my y prime, so if I figure that out, it's going to be 2 times 6.216, and then my x value is 0.4 plus 1. When I figure that out, it's going to be 17.4048, and that's going to equal delta y over the change in x, which is 0.2. So if I cross multiply, I'm going to get delta y is equal to 3.48096. So again, since that's positive, we're going to add it, so 3.48096, and when I add it to that number, I will get 9.697. So again, what I have found is if I were to graph these 4 points, it would start forming the solution curve of this differential equation. So hopefully now you can use Euler's method to find an approximation for a differential equation.